This is question 1, part B, and here we are given another question on bisection method, and we have to find out the solutions accurate to within 10 to the power minus 2. So 10 to the power minus 2 would mean 0.01, so the error should be no more than 0.01. And we're given the function here, which is x cubed minus 7x squared plus 14x minus 6 is equal to 0, and we have to find out the root of this function in the different three intervals given to us. Now I won't do here using all the three intervals, I won't solve it, so I'll just use the second interval here. So for me, I'll choose the a to be equal to 1 and the b to be equal to 3.2. So that would be my interval, and between this interval I'll find out where this function crosses the x-axis. Where is the root of this function in this interval? So for me, a is 1 and 3.2 is b. So you could do the others and see where you get as the root, and also if you want you can draw the function using Volform or any online plotting system and see where are the roots of this function. So here between the interval 1 and 3.2, let us find out the root of the function. So f of a, that means like for f of a would mean, so f of the function x is x cubed minus 7x squared plus 14x minus 6. So what we do for f of a is we put the value of a, which is 1, and here we'll have 1 cubed minus 7 times 1 squared plus 14 times 1 minus 6, and that's equal to 2. So that's f of a, that's 2 for me. Then f of b, so I'll be doing f of 3.2, and again replacing every x with 3.2, it'll give me the value as minus 0.112. So here I'll write f of b down here, which is minus 0.112, and then x is a plus b, which is 1 plus 3.2 divided by 2, and that will give me the value as 2.1 here. F of x, which is here for this particular place, we have f of 2.1, that is equal to 1.791. So that will write it down here, 1.791. And then the error is b, that's 3.2 minus a, that's 1. So we have here 3.2 minus 1 divided by 2, that's equal to 1.1. Now for the next one, again, now we'll check the sign of f of x. So the sign of f of x here is positive, right? It's a plus, it's not negative, so it's positive. And if it's positive, therefore it will replace out of this 2 whichever is positive. So this is the one that's positive, so that would replace this one here. So you can say instead of 2 it will be 1.791 here, and this will remain as it is, that is 0.112. And because now f of a is replaced by f of x, so instead of a the value of x will be taken, which is 2.1. So this will be 2.1 and here will be 3.2. So here now f of x will be 2.1 plus 3.2 divided by 2, that will give us the value as 2.65. Now putting 2.65 into our function will give us the value as 0.5521, And error, you could either do b minus a, which is 3.2, minus a, that's 2.1, divided by 2, which we'll get as 0.55, or we could just divide the previous error, which is 1.1, divided by 2. That would also give us 0.55. Again, now going and checking out what we'll replace now. So this one here is positive, and because it's positive, it will replace f of a again, which is positive, right? So instead of f of a, we'll have now 0.5521, and that's replaced. So whatever is in f of b will remain. So we'll have here 0.112 as it is. And because f of a is replaced by f of x, so a will be replaced by the value of x, which is 2.65, and b remains the same. So our root is now in the new interval between 2.65 and 3.2. And what would be the value of x right now? So we have 2.65 plus 3.2 divided by 2. That will give us 2.925. And putting that value inside the function will give us 0.0858. And now for error, I would just do the previous error divided by 2, which is equal to 0.275. Okay, now we'll check out again, which is our new interval this time. So f of x, the sign of f of x is positive again. So it will replace the positive value, which is this one here is positive. So it will replace the positive value. So it will be 0.0858. Now the rest remains as it is, except because the f of a is replaced by f of x, so a will be replaced with the value of x, which is 2.925. And here it will be same 3.2, and x will be 2.925 plus 3.2 divided by 2, and that is 3.0625. Now if you put this value into the function, what you get is minus 0.0544, and the error will be the previous error divided by 2, which is equal to 0.1375. Okay, now here we'll check what it can be or what is replaced. So this here is negative number, which means we'll replace now the negative number from f of a and f of b. So f of b is the one that is negative, so that will be the one that will be replaced now. So this will be replaced by minus 0.0544. And because f of b is replaced by f of x, so b will be replaced by the value of x. So here b will be now 3.0625, and a remains the same this time. So here we have 2.925, and so f of a is also the same, which is 0.0858. And now x will be 2.925 plus 3.0625 divided by 2, and that will give us the value as 2.9938. And putting that value into the function will give us 0.0063, and the error will be 0.1375 divided by 2, which is equal to 0.0683. 0.75. So still our error is more than 0.01 here, which we have is 0.06 and more, but we want this to be lesser than 0.01, right? So still we have to carry on our steps. We cannot stop as of yet. So let's take red color now and check here. This one here is positive, so it would replace from f of a and f of b the positive number, which is this one here is the positive number, so that will replace. So here we'll have now 0.0063, and because f of a is replaced by f of x, so a will be replaced by x, which is 2.9938. Now the b will remain, which is 3.0625, and f of b will also remain, that's minus 0.0544, and x value will now be 3.0281, and f of x would be then minus 0.0265, and the error will be 0.06875 divided by 2, that will be 0.03435. Okay, now we have more steps to go. Maybe I'll just take this to the other side because it will become too congested now. Okay. Okay, so now we'll check what should we do next. So here we have this number, which is the f of x, as negative number, so we'll take or we'll replace that with the negative number from f of a and f of b. So f of b is the one that's negative, so we'll replace that, and the number would now be minus 0.0265, and because we're replacing f of b with f of x, so we'll replace b with x value, so that would be 3.0281. That's this value here, right? Then the a will remain the same, that's 2.9938, and f of a will also remain the same because a is not changed, so that would be 0.0063, and x will be 2.9938 plus 3.0281 divided by 2, that would give us the value as 3.0109, and putting that in the function, we'll get the value as minus 0.0107, and for the error we would divide 0.03435 divided by 2, that will be 0.01715. So the error here is quite close to 0.01 now, but still it's more than 0.01, so still will not stop. We want this to go lower than 0.01, right? Now that means we need to do one more step at least. Let's go ahead and do that. So here, now this number here is negative, which would mean that we'll replace from f of a and f of b the negative number, which is this one here, and we'll write it as minus 0.0107. And because we're replacing f of b with f of x, so b will be replaced by x, that is 3.0109. a remains the same and f of a also remains the same, and x will now be 3.0023. Okay, and putting that in the function, we'll get the value as minus 0.0023, and the error will be 0.01715 divided by 2, which is 0.00855. Now this one here is less than 0.01, so we finally got our error, which is less than 0.01. So here we'll stop our calculation. We have arrived at our root of the function, which is this one here. This is our root of the function given to us in this question. So you can say therefore the root of the function f of x is 3.0023. Okay, that would be the final answer for this particular question here.